Loan application validation can be pretty cumbersome, especially when there are these many documents to deal with. Some of the documents are handwritten, which means you have to type it out later, and when you have to go through a lot of numbers just to make sure that everything makes sense. What if there was an automated solution which would take care of all of this? Look no further. This is a loan application validation system. All you have to do is select the applicant type and upload the documents as PDF. This code will take care of the rest, and you will have to do nothing else. While the code is running, I will explain what's happening behind the curtain. So in the first layer of processing, you have a classification tool. So normally you would probably expect that, oh, maybe I have to upload all the documents separately according to their type. You really don't have to, because the code takes care of it. It can identify which document is NID, it can identify which one's loan application form, which ones are bank statements, etc. to make your life easier. And how does it do it? Well, we are using a vision language model named Qwen 2.5 to do this task for us. So what it does is it's an expert at processing text inputs and image inputs. And depending on the prompt that you give to it, just like any other prompt you would give to, let's say, ChatGPT or Gemini, it can output exactly what you want. So I gave it a massive prompt, and there's a very good reason for it. The reason is I wanted it to properly understand exactly what I want from what I want from it, and I gave it as many clues as possible regarding which image is which document. The second layer is extraction. All you do is prompt to tell the model that you want XYZ data from XYZ documents, and that's it. Next up, in the aggregation layer, what you do is you aggregate the extracted data. So I intentionally extracted in a markdown format so that it's easier to convert into a pandas data frame where calculation becomes easier. Now, moving on to validation, this is the elephant in the room, because you have to ensure that all the algorithms and all the code that you implement mimics the real life integrity check processes and validation processes. So there could be cases of literal or semantic matches between, let's say, names and account number. There could be document validation issues, and some documents could be missing. Some applicants may have suspicious numbers on their bank statements. You would have to check for all of that. There are two noteworthy challenges. Number one, how do you catch valid mismatches like road number versus RDNO written on the address? They both mean the same thing, but if you do a literal check, the result would come out as false, right? So secondly, how to identify common financial red flags. So for example, if someone loads up their account with a lot of money just before the loan application to ensure that their account looks healthy, right? So there should be some sort of validation mechanism for it. So our solution was number one, fuzzy match. All it does is it returns a confidence score, which is essentially a similarity score between two different strings. Let's say could be names, could be address, could be account number as well. And secondly, implementing a lot of mathematical logic was also necessary, because let's say if someone gets an inflow which is twice their salary, that is kind of suspicious and you need to take a look at it, right? So what happens in the output layer? I have kept provision for two different types of outputs. Number one, a validation table. So against all the validation checks that were made, certain statuses will be returned. Red and yellow are worst to somewhat worse in nature. Green, it means pass. And missing means this is something that needs to be reported. Let's say a document could be missing. A check could not, let's say, take place because a certain document wasn't extracted from the bank's end. Either way, it works. The second output is simple. It's a memo-like summary if the table's too big. And all it does is it outputs, let's say, 100 to 150 word summary to ensure that if a banker is in a hurry or if a banker is loaded up, all they need to do is look at this summary and understand what actions do they need to take, right? I also wanted to share two more insights. Number one, how did I not fry my GPU? So even though I was running the code on Kaggle on a pretty good, impressive GPU, my code was still showing out of memory error and it kept crashing. So this is a problem that people working with LLM will consistently need to deal with, and learning how to optimize was a very important discovery. So the first thing I did was I did 4-bit quantization instead of the usual 8-bit. Secondly, I set a ceiling on the image dimensions, which was 720 pixel. Number three, I went for bfloat 16 instead of the usual 32 floating points. The only difference is that there will be less decimal points taken in bfloat 16. And the number four, I kept flushing the GPU VRAM after every loop to ensure that there's more space for the GPU to work with. Otherwise, this code wouldn't have been possible in the first place. And lastly, where did the dataset come from? The answer is nowhere. I had to make it synthetically. So I looked at real life forms, and the first thing I realized was there are different applicant or persona types. So I chose businessman, service holder, and self-employed for myself. Second thing I did was I looked at real life application forms and the documents that are required. I noticed that there are some in common between all persona types, which are application form, TIN, NID, but some persona types required unique types of forms. So for example, like trade license for businessmen. And lastly, by using Python libraries, I created fake data. Then I used HTML to create fake forms, and then I looped those fake forms to populate them with the fake data of people. Well, you can see the output here in the codebook now, the table that was promised, and the summary that comes after it. When hopefully I have a better GPU, I will try to connect a properly functional front end with this code and try to see if this can become an application. Thanks for watching.